Hello, my beautiful viewers. In this tutorial, we're going to continue from where we stopped. So we are still on logarithmic differentiation, and this is example 4. The question asks us to differentiate x sine x divided by x to the power of x ln x. Now, you can actually use your quotient rule, to differentiate this, but that might be stressful. That's why we are using logarithmic differentiation. So all those other differentiations can actually be done using logarithmic differentiation. Now let's see how we're going to do with this. Please, I want you to be with me. All right. Stay calm, focus, so that we'll be able to solve or differentiate this together. All right. So let's start. So first of all, you y let y be equals to the function given to us. Okay. Let y be that. So we're going to have what? We're going to have y to be x sine x divided by e to the power of x ln of what? Ln of x. All right, so moving on. Hi, we are going to introduce a logarithm, that is natural logarithm, to the both sides of the equation. Here you're going to have ln of y equals ln of into bracket x sine what? Sine x, then divided by e to the power of x ln of x, like this. All right, ln is the natural logarithm. All right. Okay. So now from here, I want you to recall that from the law of logarithm, so when you have log of a over b, so this will be log of a minus log of what? Log of b. Log of a minus log of b. And at the same time, if you have log of a multiplied by b, you know that this will be log a, all right, plus log b. So I want you to take note of these two, properties, because we are going to apply it here today in this question right here before us. All right, so this is what I'm going to have. So I'm going to have this to be ln of y is going to be, the right hand side is going to be ln of into bracket x sine what? Sine x, all right, then minus ln of open bracket e to the power of x ln of x, using this, which is the division law. Now we are now going to use this addition law, which is this. Are you getting out? So in these circled terms, this is what we are going to do. You know that here we are having x and x. They are two different functions. X is the one function and sin x is another. So the same thing here, e to the power of x is one function and ln x is another function. So now we are going to use what? We're going to use this. Now let's see how we can do that. Now from here, we're going to have ln y equals. Now here we're going to have ln of x, then plus ln of sine x, then minus ln of e to the power of x, then minus ln of x. Do you understand? Ln of x. All right, so let's move on. So now from here, we can see we have something here. We have ln of, if you look at this, we have ln of y, ln of y equals ln of x plus ln of sine x. Now here, whenever you have ln of e, this will definitely give us what? 1. That's from the law. Ln and e together like this will give us 1. So therefore here we are going to have this to be x, because we are having the power here. So ln of e will be 1, then 1 times this x will just come down. Do you understand? So we're going to have 1. We're going to have x, then minus ln of x. All right, so moving on, the next thing we're going to do after doing that, we are now going to differentiate this equation. All right, we differentiate this equation with respect to x, that is After this, the next thing we're going to do is that ln of, if you differentiate ln of y here, we're going to have 1 over y, but that is y. We are going to multiply it by dy dx, if you remember from the implicit law. All right, so here d ds of ln of x is going to be 1 over what, 1 over x, plus here d ds of ln of sine x. Now here this is ln of, I've already told you up there that when you have ln of a, it's going to be 1 over a. It means that we are going to differentiate sine x. If you differentiate sine x, you're going to have cos what, cos x. Then you are going to divide it by the argument itself. The argument is what, sine x. You have sine what, you have sine x. Now the same thing here, the derivative of x here is what, is 1. Do you understand? Then minus derivative of ln x. Look at what you are going to have here. You are going to differentiate ln x. Ln x is 1 over what, 1 over x, then divided by the argument itself, which is what, which is ln x. So take note of that. So now from there, we are going to have, or we're going to have 1 over y dy dx, then equals 1 over x plus cos x all over sine what, sine x, minus, now this one here, this one here, this x here, we have to come down here. Do you understand? So therefore, to simplify this further, that is what will happen. So we're going to have what, we're going to have 1 over, okay, x ln of x. Let's put it in what, in bracket like this. So now putting that in bracket, you know that we are looking for dy dx. So what we are going to do is to multiply both sides by what, multiply both sides by y. Okay, we multiply both sides by y. So we're going to have what, you see that this, we cancel this, we are going to have dy dx is going to be the y that we have, let's multiply it. But you know that we have the value of y already. The value of y here is x sine x divided by e to the power of s ln of x. All right, so we're going to have what, we're going to have it to be, we're going to have it to be y that is multiplying. We're going to have x sine x divided by e to the power of x ln of x, then multiply by 1 over what, 1 over x plus cos x over sine x, then minus, so I've already omitted the minus 1. There is minus 1 here. Sorry, this minus 1, I've omitted it here. The minus 1 here, minus 1 here, I've omitted it, so that's what I put there. All right, so minus 1 all over 1 over x ln of x, then minus what, minus 1. All right, minus what, minus 1. So dy dx equals e sine x divided by e to the power of x ln of x, then into bracket 1 over what, 1 over x, plus, now this cos x over sine x, when you have cos a over what, over sine a, so this will be cot what, cot a. That is from the trig identity. Understood? So therefore this place is going to be cot a, or cot x, cot x. You're going to have cot x, then minus 1 over x ln of x, then minus 1. And that is our final solution. All right, you can see the solution is not easy. All right, so please just try to watch the video, over time, so you'll see, you understand. And don't forget to watch the previous ones so that you can understand what we've done in this particular aspect of differentiation. So thank you so much for watching, and please kindly share this to your friends so they can also learn, especially to those that need it, that need it most, to the calculus student. Thank you. Bye.